Hello scholars, let's review a bit. This is standard 8A that you're watching right now. This standard says to explain and model the dissolving process. So you're going to see a lot of vocabulary here because to explain something you need to know what words to use. Model basically means to diagram or draw. So don't be surprised if you had to do some drawing. And of course this is going to be about the dissolving. So a lot of times in class I've called this standard basically solution basics. Alright, because before we even talk about more complicated things, we've got to know how things dissolve, because that's the basic of a solution. Alright. So here's just some vocab. Alright, and see if you can define these before I do, and see if I'm missing any. You know what? I already see two that I'm missing right away. Right? We have homogeneous and heterogeneous. Okay, these are two things that I already forgot. So homogeneous means that something is evenly mixed. And there's only one phase. Okay, whereas heterogeneous means it's not mixed evenly. You have two or more phases. Okay, these are both on page 6.1. So 6.1. Alright, a solute is the part of a solution that takes up less space. Good idea if you want to put these on flashcards, especially the ones you need to study more. Solvent is the part of a solution that takes up more space. Solution is the actual mixture. So this is a homogeneous mixture, meaning it's evenly mixed, right? So it's the same phase throughout. So one phase, etc. Basically, everything that we said in homogeneous right here. Solubility is how well a solute can dissolve in a solvent. And then soluble and insoluble are related. Soluble means the solute will dissolve. Insoluble means the solute will not dissolve. Okay, so solute, solvent, solution, all of that is on page 6.3. Solubility, soluble, insoluble, all this stuff right here should be 6.5. Oh, this too. And then electrolyte, that is 6. Why am I saying 6? 8. It's unit 8. What is wrong with me? I'm getting all my numbers messed up. 8.7, I think, for electrolyte. Alright, saturated. We didn't focus too much on this in class, but that means as much solute has dissolved as possible. Alright, if you try to dissolve sugar in water, it'll dissolve quite a bit, but eventually the sugar, it won't go into the water anymore. Unsaturated means you're not yet saturated, so more solute could dissolve. And then supersaturated, this is very rare, but sometimes you actually dissolve more solute than the solubility limit is dissolved. And these are very unstable because the solute really does not want to be dissolved, so they tend to fall out of solution very quickly. Electrolyte is when dissolved in water, produces ions and allows electricity to flow. So this one we tested in class with the light bulb and it lit up in salt but not sugar. Whew! So that is a lot of vocab. Alright, a lot of it's related though, so if you remember one, you'll be able to figure out the other. Like if you remember solute is the part that takes up less space than solvent, you can probably remember is one that takes up more. So they kind of go together. Little trick here, solute has 6 letters, and that's less than 7 in solvent, which is why solute is the one that takes up less, because it has less letters. Oh. Alright, so vocab's just half the battle. The other part is actually describing the dissolving process. there are two things you want to make sure you want to talk about. You want to talk about intermolecular forces, and you want to be able to talk about random molecular motion. Let's just diagram it first, though. All right, so I'll do a before and after. We'll just kind of keep it general. So let's just say it's water. The solvent does not have to be water, but let's say it's water. And let's say we're just starting with, I don't know, whatever this is, sugar, salt, doesn't matter. Okay, there's definitely more water than there is sugar. I'm just going to draw an H2O here. Now obviously there's more than two H2Os, otherwise it wouldn't be the solvent. And this is going to pull the sugar or the salt or whatever, the solute off with a strong force. And so once it does that and it moves around randomly, the solute is going to be evenly mixed or homogeneous. All right, it's going to be evenly mixed through the solution like that. All right, and that is, by definition, a solution because it's all one phase. Now, you wouldn't be able to see it because if it's one phase, you only see one thing. But I'm showing it on the micro. I'm showing the molecular view. So let's actually describe the process as well, or explain it. Now, we want to use these two. I'll put it off to the side here. All right, and we want to explain using these terms. All right, so let's just start off. We're going to say, let's just say it's salt, okay? It could be sugar, it could be Gatorade powder, lemonade powder, you know, anything that dissolves in water. Okay, so we're going to say the water attracts the salt with a strong intermolecular force. So now what's going to happen to the salt? Well, the salt will be broken apart, and then it's got to mix to become homogeneous. The random molecular motion of the water will spread the salt out until the mixture is homogeneous. I think there's not supposed to be an E here, but I haven't been consistent. I really got to look that up. Whoa, what happened? Oh, okay, there we go. All right. So let's see, dissolving process, we got vocab, we got diagramming. All right, yeah, I think that's just about it. Okay, so do the practice in the notes, and make sure you do the homework, and I'm sure you'll be in good shape. All right, come to office hours if you need it, schedule for a tutor. List of tutors is on the door, inside and outside of the room. All right, bye-bye.